Okay, so Unit 4, Lesson 5, starting the second half of Unit 4. So this is the second half of the notes. If you need the paper copy of these notes, I have them at the front entrance of the school. You can drop by any weekday. I'm here from pretty much from 7 till 3, after 3 every day. So just make sure, if you need something, communicate. If you can make it to school, that's the best way. It's hard for me to get out to a lot of families because I'm at school and I'm sometimes working with kids that are here, or I'm doing Google Meets at school. So just communicate if you need something, and I'll try and do my best to get things to you guys. But the paper copies, all you need is paper copies of the notes. So for this lesson, I had the flashcards for the vocabulary. Mainly what I want you to know is when I talk about conjugates and rationalizing the denominator. We should kind of know what a square root is by now, but we're going to talk about some properties of square roots to start this lesson off. So the first property is called the product property. So if I have a square root, I can rewrite a single square root as the product of two square roots. So the square root of a times b is the same as the square root of a times the square root of b. So this helps us simplify square roots. So to simplify a square root, we can simplify the square root of 18. And what I'm trying to figure out is which factors of 18, if any, are perfect squares. So 18 has a factor of 9, which is a perfect square. 9 times 2 is 18. So the square root of 9 is 3. So this really becomes 3 times the square root of 2. So that is my simplified version of the square root of 18. So that's the product property. The quotient property works the same way. If I have the square root of a fraction, I can rewrite it as a fraction with a square root on the top, a fraction with a square root, or a fraction with a square root on the top and the bottom. So to simplify square root of 2 over 25, I could rewrite this as the square root of 2 over the square root of 25, which is really square root of 2, which can't be simplified, but the square root of 25 is just 5. So using those properties to simplify square roots or write them in a different equivalent way. So for example 1, part A, the square root of 24, what we've got to think about is, are there any perfect squares that are factors of 24? So me rewriting that, yes, there are. A perfect square that is a factor of 24 is 4. So since 4 times 6 is 24, I can rewrite this as a product of square roots. 4 and 6. Square root of 4 is 2. So this is 2 times the square root of 6. So it's remembering our perfect squares. And I'll give you a list, a short list. 1 is a perfect square. 4 is a perfect square. 9, 16, 25, 36, 49, 64, 81, and 100. Those are the perfect squares of numbers 1 to 10. So those are the ones we should kind of have down. We should know that those perfect squares, that those numbers are perfect squares. So in part B, we're applying that product property in a different way. I can rewrite this as a single square root. I take 5 times 18 is 90. All right? Then I can rewrite this as a product of 2 square roots, which is actually where one of them is a perfect square. So that'd be the square root of 9, square root of 10. We know 9 is a perfect square, so this becomes 3 times the square root of 10. So it's knowing our perfect squares. That is the idea, okay? So simplifying using perfect squares. At the bottom here, I can rewrite this fraction as a fraction with 2 square roots. Both of these numbers are perfect squares, so this becomes simplified. 3 over 8, and that is completely simplified. So simplifying an expression using properties of square roots. The next thing, rationalizing the denominator. The reason we rationalize the denominator is to write a fraction where we don't have any square roots in the denominator on the bottom of the fraction. So in part A, I'm going to rewrite this as a fraction with 2 square roots. And to rationalize this denominator, I'm going to multiply the top and bottom of this fraction, numerator and denominator, both by the square root of 3. Because this number, square root of 3 over 3, is just 1. So I'm not changing the value of the fraction. But you'll see what happens when I do this. I can rewrite each of these products, product of the top, product of the bottom, as a single square root. So square root of 21 over square root of 9. That can be further simplified. That will become square root of 21 over 3, because the square root of 9 is 3. So this is my simplified fraction, where we rationalize the denominator. We made the denominator a rational number. So a rational number is a number that is as a decimal repeats or ends. That's what it is. What I want you to think of, we don't want a square root symbol on the bottom of any fractions we write. In part B, this is a little more tricky. So I'm going to rewrite the entire fraction, and to rationalize this denominator, we have to write the conjugate of 5 plus square root of 3. So the conjugate of 5 plus the square root of 3, all it is 5 minus square root of 3. So what we have to do is we have to multiply the top and the bottom by this conjugate. And what might help is to write these in parentheses, because we are multiplying the top by this and the bottom by this. So what the top becomes 4 times 5, 4 times square root of 3. So this becomes 20 minus 4 times the square root of 3. Okay? Now the bottom, we are multiplying a 2-term expression by a 2-term expression. So I've got to do that double distribution. 5 times 5, 5 times square root of 3. So this would be 25 minus 5 square root of 3, and then I distribute through square root of 3. So this becomes positive 5 square root of 3, and then minus square root of 9, because, I'll clean that up a little bit, minus square root of 9. Square root of 3 times square root of 3 is square root of 9. So we're going to clean this up. The thing I want you to notice is that whenever we get conjugates, that's going to eliminate negative 5 square root of 3, positive 5 square root of 3. So simplified, 20 minus 4 square root of 3 over 25 minus square root of 9, which, if I kept going, the top is as simplified as it can be. The bottom, however, I can simplify the square root of 9. So that would be 25 minus 3, which would be 22. And if you were able to simplify that far, that's what I'd expect you to be able to do. So for our next example, I'm going to start off by just saying this should be 8, not 85. So we're solving equations using square roots. So we want to eliminate everything on that side of the equation that isn't y. So that means I'm eliminating 1/4, -6, and the exponent 2. So the first thing here, since y is inside these parentheses, I'm going to eliminate 1/4 from both sides by multiplying both sides by 4. So this becomes y minus 6 squared equals 32. So I would not add 6 to both sides first. I would not take a square root of both sides first. I would eliminate the 1/4 first. So from there, I would take a square root of both sides to eliminate that squared on the y minus 6. So this turns into just y minus 6 and the square root of 32. Now, the square root of 32 can be simplified. A perfect square is a factor of it. So this really is 4 times the square root of 2. The other thing I want you to remember is that when we take the square root of something, when we take the square root of any number, there are 2 solutions. There is a positive solution and a negative solution. Because if you think about it, square root is a number times itself equals this number. So the square root of 16 is 4 and negative 4. Because 4 times 4 is 16, negative 4 times negative 4 is 16. So my final step is to add 6 to both sides. So my equation essentially has 2 solutions. 6 plus 4 square root 2 and 6 minus 4 square root 2. So whenever we take that square root, we've got to remember that plus minus, okay? Plus or minus, whatever the square root is. In part B, we're going to solve this. We've got to eliminate 2, we've got to eliminate 16, we've got to eliminate that exponent. So my first step here would be to add 16 to both sides. So this is 2x squared equals 50. Then I divide by 2. X squared equals 25. Now my final step in this is to take the square root. So x is really plus or minus 5. So my 2 solutions are 5 and negative 5. So the important thing there is to pay attention to the parentheses, pay attention to the operations to decide which steps to take. So I know this video is getting a little long, but this is the last example I want to cover. We're modeling a dropped object with a quadratic function. So it says a water balloon is dropped from a window 59 feet above the sidewalk. How long does it take for the water balloon to hit the sidewalk, so hit the ground? And we're using this height function. So we're going to use this height function for some other examples later on. But it says where t is the time in seconds, h is the height in feet, and that h sub 0 is the initial height, the height we drop it from. So in this example, our initial height is 59 feet. The time, we do not know. We're trying to figure out how long does it take. And then we are given a height to find our time from. Height of 0 when it hits the ground. So whenever we talk about height, when something's on the ground, its height off the ground is 0. So the equation I would set up would be 0 equals negative 16 t squared plus 59. So I would just be able to solve this for t. So minus 59 minus 59. Negative 59 equals negative 16t squared. We're going to get some decimals here, so we'll talk about rounding and all that stuff. So I'm going to divide both sides by negative 16. So negative 59 divided by negative 16 is 3.6875. And that decimal ended, so I'm going to write out the entire decimal. And that equals t squared. So to finish solving this, square root of both sides. So t is going to be positive or negative 1.92. I'm going to round to 2 decimal places. So t could be 1.92, t could be negative 1.92. Now if I were giving you this as just an equation to solve, these will both be acceptable answers. But since I gave you a context, there is one solution here that doesn't make sense in the context of this problem. And that's the negative 1.92. Positive 1.92 makes sense because time makes sense as a positive value. So when I give you a context, just make sure you think about answers that make sense in the context and don't make sense in the context. So yes, again, this is a long video, all right? But the idea is that these lessons get more condensed, right? A lot of information condensed into one lesson. So just make sure that you're taking your time through them and that you're pausing, giving yourself breaks from my voice, all right?